Today I want to talk about our efforts to use structured data in wikitext or go beyond wikitext to use structured data. We last time on the SemanticLab conference, we already showed how much is possible in sticking to the MediaWiki text itself. But in the meantime, we developed some strategies and technologies to go beyond this. So we'll first show the conventional approaches. What we did what was the problem in using the conventional approaches, and what we do with the multi-content revision feature of MediaWiki, and what we build on top of that using JSON, JSON scheme, JSON LD, and also the connection, of course, with the MediaWiki. And finally, of course, I give short demonstration how you can use these features. Conventional approach is that we have a MediaWiki code that is unstructured text mixed with some templates and parser functions. So we put this all in one slot, all in the main slot. And it would also give, of course, there's also the option to use a content model JSON. Then you have the option to store some JSON in the MediaWiki page. But of course, you cannot mix both. So you can have a rendered page, or you can have structured content in the page. If you want to have both, you have to spread it over multiple pages. And then you have to manage all these pages you created. So we did, of course, develop this scientific stack with MediaWiki, and we use all the templates really to store information within wiki pages. And of course, we're not the only one that did so. And of course, you can do a lot of fancy stuff with templates. You can have text and numbers, also strings. You have arrays. You can nest some templates. You can even translate this in JSON equivalent. And translate it, for example, all strings to strings, numbers to numbers, arrays in lists, and also nested. Nested structures are possible, of course, if you integrate a template here as a nested object in the JSON. This is all possible, but of course, we also recognize the problems here. So in wiki templates, there's no standardized delimiter for arrays, so you have a semicolon, or you have a comma, or something else. If you have a list of templates, there's no delimiter at all, so you can just align templates. You can also throw in a string in between, it's all valid. So it's really hard to cover all these special cases, how templates could be structured. And extensions like page forms, of course, deal with that to integrate the data. And extensions like SemanticLab, of course, use these templates to extract information and store it in the database and make it accessible for queries. But in general, you need parsers to interact with the wiki page to interpret this complex structure. And these parsers, of course, are very need to deal with all these special cases. And there's no general approach because all the existing tools out there, of course, are not aware of wiki text. So you write your own code. And as I said, sometimes you have just to guess what is the actual data type and if it's an array or not, and such things. We then extended the main slot of with an additional slot with JSON data, and this slot has then the ability to with the multi-content revision feature, we have the ability to really use both. So the main slot for wikitext to have some rendered page content and JSON data slot for structured content. So the main slot, as usual, wikitext, and the JSON data slot is dedicated for structured data. And so we have this nice combination of both. If you have some JSON, then you may asking for, okay, isn't there also an option then to somehow define what is a valid content, what should be there? Can I automate the validation of this content? Can I have a proper description? And of course, the standard therefore is called a JSON scheme. And so why not add an additional slot for JSON scheme beside the JSON data slot? And so you can have a proper scheme for your JSON data. And a scheme then describes what we have. You have basically always an object on the root level, which has some properties like text, number, array. And every property is properly defined by its type, and a lot of additional keywords that are defined in the JSON schemes standard to actually describe the shape, the data type, and also documentation attributes like title, description, and so on for structured data. Mapping this to the wiki concept, of course, means that we have the category as kind of a class concept for wiki pages and a kind of maybe item namespace where we have the instances. So actually, the scheme within the JSON scheme slot of a category can then shape the content of every item in that are located within this category. Okay, the next point, yeah, it's not really looking fancy, but the next point is, of course, if we have JSON scheme and JSON, there are tons of tools out there helping us to create, interfaces to it. So we have, for example, a scheme. We also describe for example, a title. We can also use multi-language annotations in different, for example, English and German. Then we have our property definitions. For example, we say our string, our color property is not just a string, but it's a string representing a color as a hex code, for example, and we have a number which is, of course, should not be a string, but a plain number in a JSON. And what we get from libraries like the JSON scheme-based JSON editor, he directly interprets the scheme to render a form, and this form, for example, then has this color dialog. So it just interprets this input field as a color and also validates that, for example, number, the string 1 is not a valid number, but the corresponding number is valid. So it automatically validates that. So we basically, with no additional effort, if you stick to existing standards regarding structured data, we get a ton of tools improving our work here. Okay. The next step is, what is, okay, now I have a scheme in my JSON slot in the category namespace, and I have all these instances of categories, but of course, MwJson supports subcategories. Can we not also integrate this in our in our structure? Yes, of course. JSON scheme also supports the referencing schemes. So, for example, with the keyword all of, that means if we have this subcategory within a category, and we just want to extend the definition of the superclass, we can do so by referencing the superclass with all of. And we need, according to JSON-D, we need a valid JSON pointer. So we point to the category page in and particular to the slot where the JSON scheme is located. So we somehow load the JSON scheme from the supercategory and extend the definitions that are made here locally, like additional property with the properties already defined in the superclass. So same as inheritance works in general in object-oriented programming. Yeah. Next step is, of course, we want continue to use semantic information. So do not only put some structured content here, but also link the content. And what we can additionally use from the JSON scheme family is the JSON ID. Here we have so-called context definition. So it means that if we have a JSON document, we can define in the context a semantic meaning of properties. And of course, this is directly related to what Semantic Media Wiki does in templates. So you have a template parameter, like described here, and you map this template parameter to semantic media property. If we want to make this more general and going beyond Semantic Media Wiki, also interpretable by any other actor out there, we can express the same information in the JSON ID context. Also interpretable by any other actor out there. And yeah, so what we have here, for example, we have some namespace prefixes that define the schema org, for example, or the property namespace within the wiki itself. And we can then map some properties we use in our own JSON, like image, to map those properties to both. So we have then, for example, if Google visits our page, it knows an image is an image. And if we want to internally map image to some semantic media property, we can do this as well. Finally, of course, even if we have structured data in JSON, we don't want to lose all the nice rendering features that MediaWiki offers. So finally, we add we have even more slots. So we have a header template and a footer template that helps category pages to define what should be displayed on the top or on the foot of every instance page. And we also have a header and a footer slot, just making sure that the structured data is also somewhere displayed if you want to. For example, if you have a footer or header template in the category, it's a normal wikitext template, like having any parameter in it. You can then define in your scheme that you want to have this property myList, which is of type array, so it's not a single value, but a list of values. You can then define an evaluation template that gets applied before this template is called. For example, you can specify mustache wikitext interpretation. So it first expands the list to single elements, and then it calls this MediaWiki template on top, making this list to a list of wiki links. And finally, this list is just embedded at the page where you want to have that. And the point here is that you can have a property-specific template, not only covering wiki text, but also additional template syntax like mustache. And of course, point here is that mustache is also capable, is directly made for for consuming JSON, meaning also consuming lists of nested objects, while a wiki template, of course, can only consume plain literals and no lists directly. Therefore, you need additional parser functions. Currently, these wiki side features are implemented in Lua, so the complete interpretation of the JSON and the JSON scheme and the JSON ID context is done in Lua. Also in combination with the WSLot extension. This is, of course, not ideally and should maybe move to PHP, also for performance reasons. And in general, of course, it's somehow annoying that we need just these 2 slots to make the parser interpreting the JSON. But currently, I did not find any solution that provides a hook in the MetaWiki core that is somehow slot aware of the content he delivers. So you can, of course, have a hook on and extend the content, but you have no information which slot you're currently parsing. And so, for example, if you apply this hook and you have more than 1 slots, you get injected content multiple times. And so currently, the easiest way is to provide this dedicated slots for this feature. Okay, it is very theoretical, but of course it's nice to have a demonstration. So we have so this page here I put in the chat, so you can read this your own. Of course, this page is itself a demonstration of the technology stack. I just have showed, and you can also use the demo platform. You can log in with your archive ID if you have one, and also use this feature. So as an example, if you have, let's say, something very basic like an event, then that's represented by the structure here, that an event is in general an item, and an item is in general something very generic like an entity. But what is the difference between a general item and an event is, of course, that the event has a start and an end date. So if we look at the scheme of the category page of item and the category page of event, we will notice a difference if we look at the slots of both category pages. In item, we have, for example, in the scheme slot, we have just the basic information inherited from the entity, that is label and UUID and stuff. And in event, we have extended the scheme by using additional properties like start date and end date. So that's what is specific for a time-related entity. And if you, for example, have the opinion, I have an even more special event, you can easily extend this. So you can just say, okay, this event definition is not enough. So you can create your own subcategory. Maybe call it my special event type. And this inherits all the properties from event. So it's same as subclassing in object-oriented programming. If you want to edit the properties, we also want to have a more visual form to edit the scheme. So we already have a prototype here, but technically you will have to extend the property section here. there's only a default already generated, but you can write, for example, my string property, and let's say that's of type string, and you already have a custom property defined. And if you want to map this to a semantic media property, you will have to extend your context. So write here that my string maps to as string, for example. And so that's it, how you extend the definition of this class, of this category. And if you want to create an instance, that's the button here, create a new instance. And now you have scheme-based editor that's directly uses all the definitions from the schemes, not only from the current class or category, but all the categories that are super categories. So you have, of course, your own created property here, but you also have, for example, the start event, the start time of the event and the end time that are defined in the base event class. And dates, of course, are printed as a date, and you, of course, should give your entity a name. And after saving this, you get your wiki page for this specific event. It also has this info box automatically created for this structured data. You have also the rendering of the base class and the base class and the base class. They are stacked here. And if you scroll down, you will also have the semantic properties that you defined in the scheme. Should also be the custom mapping we just have defined. If I'm not, okay, maybe I did some misspelling. So basically, it's easy to extend a category, and then using this definition to create new entries in the wiki. And of course, beside this editor for structured data for the different slots, you can, as always, use the normal wiki visual editor with all the features, also the features I showed last time, like embedding, like a sketch, for example, in the wiki text to make some hand drawing. So it's a side-by-side existence of structured data and unstructured data, like in this example, for example, draw something by hand. And that's directly embedded in the wiki page. Of course, the main argument to use standards that are established in the whole industry is that they directly understand what you are storing information in your wiki. For example, Google has this tool that can validate the structured context in your own wiki pages or in your own web pages in general. And if you, for example, use a predefined scheme for something that Google already understands, like event or recipe for example, if you want to describe how you cook something, there is at least one reference example. So you have also here the scheme behind that describes preparation time, processing time, ingredients in the JSON scheme, and it helps you, for example, to create this content in a structured way. But the scheme also provides the proper mapping to scheme org, which is understandable by Google. So that means if you put this page in the Google validator for rich search results, it should directly understand what is written in the structured content slot of the wiki page. This is done by embedding JSON LD. So it's nothing that we need to process somehow because we already have JSON. The JSON LD context is defined in the schemes. So if you, for example, have a look at the HTML code of the page, according to the industry standards, you have this JSON LD star tag, script tag here in the HTML header. And here you have all the JSON content from the JSON data slot of the wiki page, combined with the context definition of the JSON scheme slot of all the super categories. And combined, they are valid JSON LD, and Google can understand this properly. So it's a valid recipe as something that is identified as an image, something that is identified as a preparation time, and so on. And in the expectation that Google and other search providers will rank search results higher that are machine readable described, this should be a really good point. But beyond Google and Co, of course, it's also now a lot easier for us to connect to the wiki system using other programming languages like Python to use the structured information to automate various tasks in our business. But that's what I will show in the lightning task tomorrow. Okay, I think I'm pretty on the time limit. So yeah, if you have any questions, I'm happy to answer them. I cannot hear you. Sorry. I cannot hear you. Sorry. Okay, yeah, sorry. One question was whether OpenSemanticLab is a good metadata management solution, and that's totally as it intended. Okay, yeah, sorry. One question was, and because we have of course, we as a scientific research institute, we have a lot of complex workflows. We have different devices in the lab, and it's really hard to keep the information accessible. And we also want to automate things. So we need, for example, Python services to access metadata information and automatically make some stuff in the background. And I mean, this concept, JSON scheme, is really industry standard. So it also empowers us to really use structure definitions that are already out there, so we don't need to translate them in some wiki specific. So we just take them, and most developers out there are capable to write a JSON schema or already have. So it's really an improvement. And tomorrow I will show that it's also way easier to generate code, like for example Python code from a JSON scheme. So you directly you can enable these features also in programming with other languages. And another question was, what is the difference between other structured data tools like FlexForm and page properties? Of course, FlexForms, for example, we had also discussions. So FlexForm has this focus on embedding, editing HTML form in the page, and I think really it's great to have this embedded editing feature. But for our approach, it was really also necessary to really speed up the process of defining forms. So, and also incorporate this inheritance structure. So it is nice to have the option to define a form, but we have so many entities to manage that it really would be hard work if we need to define a form for every variant of an entity we have. And applying this inheritance structure is really something that makes this work very easy, much easier than before. So if you want to have a structured data about user, you do not rewrite a form, but you just inherit the form from person, and you just add the username property to it, for example. But FlexForms of course, is also slot aware, and that's really the point where we already are connected or even develop some features together, because we both rely on the multi-content revision slot. So at the end, of course, there are a lot of options in editing structured data. But I think if it comes to the core, what we need from the MetaWiki core, the requirements are quite the same, and FlexForm is also supporting JSON right now. So I think that's really could of course also improve the interoperability between all these tools. If they, for example, can all edit JSON, or all can pull some definition from the JSON scheme, then maybe they can just even can be well combined. And the last question is, okay, a more comment that JSON-LD compatibility was requested by familysearch.org. I'm happy to hear that. So if you use JSON LD in JSON schemes and JSON and JSON data slots, then this feature is directly fulfilled.